Okay, so now that we have 5 exponential shortcuts finished, here is a 6th one, right? The idea or the concept of an exponent of 0, right? What happens when I take a number, let's say 3, and I raise it to the 0 power? Now, first of all, we have to understand that this is a little weird, right? Because going back to a couple of videos ago, right, when I say 3 squared, right, the idea is the number 3 working as the base, and the 2 exponent is telling us to take that base and multiply it to itself twice, right? But this is a little crazy because this is basically telling us to multiply 3 to itself 0 times. And, how do you do that? Mathematically, it just doesn't make any sense, like multiplying something to itself 2 times or 1 time or 5 times. So what does it mean to multiply something to itself 0 times? All right, and then unfortunately, a lot of students think the answer will be 0. All right, but it actually, believe it or not, is going to equal 1. All right, so now I have to tell you why do we do that, right? So first of all, this is weird. So how do we get this to be 1? So let's go look at some other things. So here's kind of a quasi proof of why this is the case. So let's take a look at the expression 3 to the 5th over 3 to the 5th. All right, there's nothing unique about that. We can have used any number we wanted, but it's going to get us where we want to go. So there's 2 ways that we can think about that expression. One is to use the quotient rule that we just learned. Right? The quotient rule says that if we're dividing by the same base, I can keep that base and take my top exponent and subtract my bottom one. So if we follow that exponential rule, what we end up with is the thing that we're trying to figure out. Well, what is 3 to the 0? All right, so that's one way to contend with that expression. Now, of course, the other way is just to use our idea, our concept of what an exponent does. So 3 to the 5th, well, that's just 3 multiplied to itself 5 times. And then down in the denominator, we have 3 multiplied to itself 5 times, I think I said 3 up here. All right, and then what we have is basically a bunch of dividing out. 3 divided by 3 is 1, 3 divided by 3 is 1, 3 divided by 3 is 1, and so forth and so forth and so on. So what we end up getting is that evaluates out to 1. Of course, maybe some of you saw that at the beginning. We know that any number divided by itself is 1 anyways, but I wanted to get a little crazy with the exponents. So here's where we're at. There's this idea in math called transitivity. I don't even know if I'm spelling it right. All right, transitivity. But the idea is that this expression is equal to 3 to the 0, and at the same time, that expression is equal to 1. And so since 1 and 3 to the 0 came from the same source, if you would, then it implies that 3 to the 0 is also equal to 1. And so there's basically your proof why 3 to the 0 is 1. We can play this game with any number. So, it could be any number you dream up. It could be 1,625. If I raise that to the 0 power, what I get is 1. It could be a variable, right? When I raise it to the 0 power, what I get is 1. All right? And you usually see in practice, you see a to the 0 is equal to 1. All right? However, there's one thing, all right, now that we know what the rule states, there's one number that a cannot equal. A cannot equal 0. And the reason being is if we come back to the proof I shared with you, right, notice the 3 happens to be the base in the fraction. So if I have 0 to the 0 power, right, what I end up with is 0, like let's say to the 5th, and 0 to the 5th. And we have all kinds of problems here. Number one, we know that division by 0 is not defined. All right, and then sometimes we know that division into 0 is 0, and then a number divided by itself is 1. So this is really crazy. It actually requires more math. So our rule for exponents of 0, long story short, is anything to the 0 power is 1, with the exception that that base can't be 0. All right, I'll never do that to you guys until I see you in a calculus class one day. That's when we handle 0 to the 0 power. But right now in our nice algebra class, anything to the 0 power, no matter what this base is always equal to 1. All right, so we'll use that in some situations, but there's your sixth rule. We have a seventh one that we'll consider in 4.2. Let's now move forward. Now that we know all our six rules, let's go apply them to a bunch of different expressions. I'll see you guys in that next video.